Welcome back to Pulse of the Park. Ever wondered how your favorite park characters move so lifelike? Well, it's because of these pneumatic cylinders. And today we're going to look at how they operate. A pneumatic cylinder is a linear actuator powered by compressed air to supply force on a load. The assembly shown here is the most common type of double-acting pneumatic actuator used in industries. It consists of a piston rod. This rod transfers force of compressed air to the load. Cushioning pistons are assembled with this rod. These pistons prevent any hard shocks at the end of the stroke by enabling the piston to stop slowly and gradually. The piston reciprocates back and forth when there is pressure difference between any of the two sides. A static seal ensures airtight sealing between the piston and rod. Piston guide rings are assembled to prevent metal-to-metal contact of piston and cylinder. Piston seals provide airtight sealing between the cylinder and piston. This whole assembly then goes into a cylindrical bore. This cylinder is generally made up of aluminum or steel. A cylinder cap encloses the cylinder chamber on one end and the cylinder head encloses the chamber from the other end. Cushioning buffers and seals are installed on respective ends. Captive adjustable cushioning screws are installed on each end. These screws enable user to adjust the optimum cushioning at the end of the stroke. This whole assembly is held together with tie rods. These rods also provide compressive and tensile strength to the actuator. Air fittings are screwed into the ports through which compressed air flows in and out of. A pneumatic valve is connected to these fittings using pneumatic air lines. The valve shown here is a 5-port, 4-way valve. The ports, A and B, are connected to the cylinder. Port P is connected to the compressed air supply unit. Ports R and S are exhaust ports to which the pneumatic mufflers are attached. Now let's understand how a pneumatic cylinder works. The compressed air is supplied through inlet port P of the valve. The valve directs air to a particular direction which we can observe in the animation. In this case, the air is directed to port A. This high-pressure air is then transferred to the cap end of the cylinder, which therefore pushes the piston towards the head end. This also pushes air from the head end. This exhausted air travels through the other hose and reaches the valve. The valve directs the air towards port S and allows it to escape through the pneumatic muffler. The air muffler helps to reduce any noise produced during exhaust. The process we just observed is the extension stroke of the actuator. During the retraction stroke, the valve directs compressed air to the head end of the cylinder. This causes the piston to return and air in the other chamber escapes from the exhausted port R. Here you can see a real-world example of the pneumatic cylinder in action. Cylinders come in all sizes. As you can see here, these are very small. Notice how there are two that are back-to-back that turn the eyes left and right. The cylinder in the center controls the eye blink. That's it for our look at pneumatic cylinders. And now that you know how some of your favorite animatronics move and come to life, let me know in the comments what's your favorite character. If you found this helpful, be sure to subscribe and hit that notification bell so you don't miss our next video.